right, last example in the notes. A ball is thrown vertically upward from a ground with an initial velocity of 100 feet per second. Determine when the ball will reach the maximum height round to 2 decimal places. And then it says determine what the maximum height will be. All right, if you think back to our applications, we actually saw a problem similar to this. We were shooting an arrow off of a ledge, but there we were looking for how long until the arrow hit the ground. My wording has changed slightly. Now I'm looking for when will the ball reach its maximum height. Well, let's first just talk about what's happening. So a ball is thrown vertically upward. So it's going to go up for some amount of time, and then it's going to eventually start to fall, and it's going to land back on the ground. Now, I've thrown it up with an initial velocity, and we said that that was v sub 0. Now, let's go back to that projectile motion formula, and let's start filling in the things we know. So I've got h equals negative 16 t squared plus v0t plus h0. That will be given to you in the problems. It'll be given to you, it was given to you back in the 16.4 in the application notes. What I need to fill in is the stuff that I know. So first let's fill in the velocity because that one's easy. Velocity v0 is 100. T is going to be my time. Now, h0 and h were the heights. H is going to be the height when it ends, and h0 is going to be the starting height. So here, I drew this picture because this ball is starting on the ground. From the ground. And so because the ball is starting on the ground, the initial height is going to be 0 because the ball is starting on the ground. And then because I am looking for the maximum height is going to correspond when the ball is right there, which just so happens to be the vertex. And so I'm going to find the vertex of this thing, negative 16 t squared plus 100t. And so this one's kind of nice. The vertex probably would be easier to just use the formula than trying to write vertex form because the numbers aren't really small. And so vertex form, the vertex is going to be negative b over 2a. Well, negative b, which is negative 100, over 2 times a. I'm going to type that thing in. And I get out a x-coordinate of 3.125, but it says round to 2 decimal places, so we're going to say 3.13. Now the x-coordinate is here. I'm looking for determine when will the ball reach its maximum height and what is its maximum height. So here's my when, because that's my time. So 3.13 seconds. What is its maximum height is going to be the y coordinate because that's going to be how high up on my graph I went. And so the y coordinate is going to be plug in that 3.13 for x into my equation. And so here's my equation. Where there was a t, I said x. Where there was a t, I'm going to replace with 3.12 3.12. And then I'm going to fill all of this stuff in. You can type that straight into your calculator. And we get out, oh, and this should be, I'm making all kinds of errors. This should be 3.13. 3.13 equals t, because that's what I found. And now I'm finding the height itself, which corresponds with the y-coordinate, but technically is h in the context of my problem. But y-coordinate, like we think of with the vertex. This should say 3.13, 3.13. And so now, when we type that all in to our calculator, I got out 156.2496. It says again to round to 2 decimal places. So 156.25. And remember, my units here are feet because it is my maximum height.